Guowei, thanks for joining us. Say hi to the audience.
Hi everyone. Hi Xiaohan. Thanks for having me.
Okay, let's get started. Who are you? Can you tell me more about who are you and what are you doing?
Hi everyone. Hi Xiaohan. Name is Guowei Lan, and I'm the founder and CEO of Kynooe, and we are building the world's first fully modular robot.
Kynooe is almost the first one of hardware portfolio in XIAOXIAO Fund investment. So the moment that I invested you seem like a little bit excited and flattered.
At the moment that I received your email, it's quite big, exciting, actually overwhelming. Of like our product and our team is really being proved in the capital markets that is doing something valuable. So what brought me here, and I asked. So I think being an entrepreneur is something I meant to do. I came from family with entrepreneurship, and I have a role model. And when I was in high school, I kind of have this feeling that if I have a chance, I want to have my own project to create something valuable. So I went to Germany to do my bachelor's study, and I was doing the very traditional mechanical engineering stuff, like the car industrial related to, and also some 3D printed turbine engine. So I worked with several projects in the very traditional or classical mechanical engineering stuff. And after my graduation, I worked at Porsche, the car manufacturer. I was basically doing some engine optimization stuff for the 911. That's sounds great, right? And that time ChatGPT came, and then boom, the world sees how powerful it is, the generative AI. And then I start thinking, I should do something with it. This is quite powerful. You see that the generative AI is something I've seen could generate a high amount of value to me at least. So I see how good it could empower my life, my working, my work, and also my personal life. And I start thinking, how can I, as a mechanical engineer, have some relation to this generative AI? And then robotics is I think robotics is the best option at this moment. And also now it proved robotics is quite hard today, so it really does. So I went to ETH Zurich to do my master in a robotics lab. I was at the beginning I was building a space grade motor, decided for robots that being deployed in outer space, right? And then I luckily got a chance to get into manipulation of the real robots, the legged robots. The legged robot with an arm on top, so they can do locomotion, they can do a little bit manipulation. And the project is basically to build a brain for the robot to do decision making, right? You have the embodiment, you have your robot maybe in the office, you ask the robot, I'm hungry, bring me something to eat. And the robot will then automatically go to the kitchen, bring you an apple, and then put it on desk. So my job or the project, or actually my master's thesis, is about we actually published a paper and to build a brain for the robot in a traditional way. Now I'm talking in traditional way. It's actually a hierarchical structure or hierarchical architecture of this brain. Now people are talking end to end. I think we will get to it later. And yeah, then during this project of building this robot brain, I have a lot of experimenting stuff with the robot, and then I realized this robot is really cool. It's really useful in the lab, in the robotics lab, maybe also in the industry. But one day, if saying we want robots to bring practical or customer value, we need to deliver this or ship this robot to everyone's hand to make them to make everyone have access. Access. I mean, in the software side, also in the hardware side, you cannot have this thinking or prerequisition for everyone able to code to control robot. No, that's not what we wanted to do. We wanted to ship a product, a product that everyone can use it right out of the box. So then I start thinking, on the hardware side, what could be a game changer? And then I came up with an idea of fully modular, which means the robot is made out of different modules, and this modules is like an iPhone. You can use it right off the box, and then you assemble it easily by just click, and then you can just use it with your app, with your phone, and then with maybe now everything. So
well, it's pretty interesting because the area that you worked before, especially in the lab, is just a very small amount of people could know what's going on in robotics. But your vision about Kynooe, you wanted to shape the product to the big amount of customers, especially end to end, like customers like me, into the household robotics. So the vision has changed a little bit.
But why I'm building this company, why I'm building Kynooe is actually, you said what I say is totally right. We want to make robot accessible for everyone. Everyone here, what I mean is with or without any preconception or know-how about robotics.
Well,
just like
yeah, because this point resonates with my thesis because, well, I just look backward the investor portfolios I did on the software side. They are, I always pick the builders in software side. Well, in the hardware industry, I also wanted to find some builders. Well, I can say there are a lot of entrepreneurship from you, and also you are building something great. But
thank you. I mean, it's really our pleasure to be the first hardware project or case of XIAOXIAO Fund. So actually, I was we have a nice talk about the vision of. I think we'll get to it later on. But now let's keep going.
Yeah, well, my point is I have to, because your customer is more like the builders, the makers. They're not directly to the consumers. Can I say in that way? Because you have to let your users to build it upon your foundation.
So, exactly. The idea is we the product we are shipping to, or our go-to-market strategy is, first we are targeting the group of people that have or that really willing to get their hand dirty with robots. It's the creators, it's the builders, and many others. So we are targeting these two group of people first, and then by using our product by using this modular design robots, I think we could generate a bit more different robot shape or a shape of machinery for everyone to use it. Like exactly, we are building a platform and we're building a robot ecosystem, a foundation for everyone. And maybe at first for the builders, for the creators to create a new species, a new form of robots that is easy to use and that could also generate real value. Okay, it can build stuff, it can make stuff, it can help you on your desktop, on your everywhere in the household environment.
Yeah, so the path, the roadmap in front of you could be divided into different phases. So phase one, you have to like confront with the builders, but phase two maybe will lead you to the more consumers, right? Yeah, that makes sense.
Exactly. Yeah, that make totally sense. That make totally sense. First, we are launching this product on a crowdfunding platform called Kickstarter, and the people on this on that platform is exactly what we are targeting to. So as I say in the phase one, yeah.
Yeah, I know you've already the Kynooe because you posted it on not only Randall in China but
Yeah, we
also
posted.
Reddit, yeah, in
Yeah, we
US.
posted on Reddit, and how lucky we are. People love us.
Yeah,
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 the design and the way that we redefine the way we define robots. Yeah, I think now what we are doing is to really optimize, and building hardware is a totally different story as building
yeah, exactly.
as building software. We are building software in house because we have this control system on the lower layer. We have this user interface on the upper layer, and then we know iterating software is an overnight thing. But iterating software, we took a month. We actually hear from one of our potential users to optimize the motion a little bit more. Then we spend a month to iterate, and yeah, so yeah, the 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 mission is to provide a stable and also easy to use product for the first group of our potentials, because people love us, and our job is to keep this passion of everyone going, and just make everyone happy um, on a software side. Yeah.
Yeah, I'm curious about what attracted your users, because what kind of use case you think would be? 'Cause yeah, you
Yeah.
just told me some users want to use it as like after the 3D printing jobs.
Yeah.
So could you describe it?
Yeah. Yeah. There are many like saying this. What's the word? Uh, Customer co-creation thing. Like people wanted to use these robots to like when I think about it, there's many use case on the desktop environment. Like people wanted to um, people wanted to install it beside the 3D printer, and then after each print, you could remove the filaments, and then start a new printing, and then so this is a very common and very
There's that one have the desire to use Kano because they probably the similar group of people who are using bamboo like 3D printer beforehand, right? So
yeah
they just have this kind of demand, but bamboo can't fulfill their requirements. So
yeah
they just
yeah
have to find another one like Keynote, this kind of stuff to fulfill their
yeah.
requirement.
They need we will need a device to do the manipulation. And there's all kind of manipulation. We like picking up an apple from the desk. There's a manipulation, and picking up the well printed parts from the printing beds. and then we start the printing whole process all again. This is one very common use case, but we also see other people are doing this already, and by using not a robot arm but a very specific device that specific designed for a 3D printer. So yeah, we could do what other people know. I mean, yeah, this is just one case. But at the end of the day, what we want to do is to we define a several use case to maybe we are doing something could really generate to or lower the to generate some value, like to tidy up your desk, to put every trash on your desk into the bin, and also, but really important is we what we're thinking is to have a easy to use software hardware on your desk, and then everyone could define what they want to do. Like if they want this robot to hold a camera to do some eyes tracking or face tracking, and while you are walking or while you're cooking, you are opening a cookbook on your iPad, and then this iPad or this robot can hold this iPad and for your face. This,
Wow.
this this kind of use case, and this is kind of the use case that we wanted to shift to our users. And I think for the product side and also the whole ecosystem, they will be a new. They will always like generating new use cases, and our job is to make this use case or make the hardware mature enough for them to build up their ideas. Yeah, this more or
Yeah,
less why.
so at this stage, Kynooe just provide the platform for users to try to create something upon.
Yeah, this is a platform. This is a hardware platform. This is hardware community, if you will.
Yeah, I want to continue on the product because I'm so curious about this. Why modular design? Why modular? Because I've already seen a lot of stuff like the mechanical
Yes,
arms, and especially in
yes,
Shenzhen, it's very common.
yes.
But I think why you can garner a lot of attention from users because you just use a very unique design.
Mhm.
Yeah, you're just the only one that I see to do the modular design. So
Yeah,
how does it come out, the idea?
yeah. Um, so from bottom up is the time or is the time I I worked with robots, and I I noticed and also realized uh, the the form of robots that we are seeing right now, we are seeing in the market, it's more targeting the research and maybe also the industry environment. And but they're great products, but there's a space, they're empty. There's also a hollow space for another product that everyone could buy and use. I mean, hey, everyone, I mean, really everyone, with or without any robotic know-how. And so I start thinking, and I start and I start thinking how um, could could we could we make or build a new species for everyone easy to use, and then come up with this fully modular design. It has its goods and it has its uh, disadvantage as well. But from what I see, this is the this is the best, or this is the my this is my taste. Like this is like what how I wanted to define and and deliver to the users. Like I want to I want to deliver a robot to you, to
Uh-huh.
Xiaohan,
Uh-huh.
and then I don't want it to let you to like open a box, and then there's thousands of wires you have plug in there, and then you need to hold your laptop and then do some cack and build. No, So what's going to do is just like you open a like you have a new phone and you open a box and then you switch it on and then you can use it, and that's it. So actually I did a lot of thinking about hardware, and also I need to verify if this fully modular design is working. And then we managed to prove it, that the motion and that the control system and also the compatibility of hardware of the state of the art AI model works with our own design. So now then I think we are I think that's a nice idea.
Have you ever met some challenges when your user try to do some specific jobs, especially like how much weight can the Kynooe
Mm-hmm.
take, and
Yeah.
how does the consistency look like when they do like the repeated tasks?
Mm-hmm. Mm-hmm.
Yeah,
Yeah. 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 So the
something.
payload the repeatability, I think that's the
Mm-hmm.
word. And so the payload now what we design is about a couple hundred grams, a couple hundred grams, a
Mm-hmm.
couple hundred grams. And now because what we are so what you have seen what you see or what everyone sees from our videos is the prototype that use 3D print to build 3D print to build. So it's quite heavy, and so that's the first part. So the payload is about it's a it's a range about 300 to 500 grams uh, in the in the shape that in the 5 degree of freedom or 4 degree of freedom robot arm. And the repeatability is about we we didn't measure it because I think um you the the robots that you used in the house environment, or we call it the service robot. I don't know
Mm-hmm.
the word. They don't need that high precision. They don't need that higher repeatability like the
Mm.
robot arm that we seen from the car industry when I was at Porsche. And because what you expect this robot to do is to like you to pick up an apple. Pick up an apple. You don't need that higher. So an apple is like 200 grams. It's easy, and then pick up apple or doing some close folding. It just you can easily manage to do it with a robot arm, like using uh maybe one. Mm, yeah, I mean, um, for the service robot that we will see in the household environment, from my perspective, they don't need that high precision. So what and it's always a balance of price and and this performance. We can build a robot like up to a couple $1,000 or maybe more, and then you're gonna have a higher precision. Maybe then, but but we don't need we don't need that redundancies in a robot that you install in your hand, install on your desk, and do some simple stuff for you.
A modular design, the length of each modular and the size could be tailored, right? And
Yes.
how did you measure it? Because you're gonna have a bunch of customers, different users have
Mm-hmm.
different requirements. How did you
Yes.
tailor? Yeah, how do you productize Kino?
We will provide several lengths. We will provide something from 30 centimeter to 90 centimeters, so different standard length, and then everyone can choose their own their own version, their own version. Everyone can choose their own version,
And also the color?
and also the color a little bit. Yes, yes, definitely, and also the color. We have our own color. We have our own color, and if you will, we can. Yeah, we will definitely launch a customized version.
Mm-hmm.
Yeah, for everyone willing to have some or show their own personality or characteristic with Kino. And most important thing is how we could build a digital model. It's like saying you want to switch length, you want to switch from 30 centimeters to 90 centimeters. It's easy, you just click, that's it. But for our job is to really to build a digital model corresponding to your configuration. And so that's the part we are talking. We are managing to solve. Yeah.
If you could name 3 indicators that your customers pay attention most, 3 features
3 wishes of
like appearance, the weight that you can carry, the
so the first one is definitely openness. It's
openness.
how we I think that's the reason why it got a lot of attention on the social media is people see the potential of using it, like we talk about like as a foundation of building different robots, building different machinery as well. And so openness is definitely one of these. We're asked to open source everything. We are thinking about it. We will open source definitely most of the framework, the low level control part, because we have actually our vision is to make robot accessible for everyone, and then we definitely want to provide enough or more than enough freedom for everyone to use it. So we'll definitely go open source. And then the second is appearance. Yes, definitely. So we are delivering, we are shipping product to your hand, to everyone's hand. I think appearance is definitely one of the most important aspect. So the third one, when we think about it, is it's the third one is performance. Yeah, I would say a very general performance, because performance related to the smoothness, how smooth this robot can move, and then also payload is one of the key feature, and also its adaptability to different shape. Yeah, this is also related to openness. But anyway, these 3, I think that's the key. That's the key. This is also the key. This is also the key. This is also the this is also our vision. Like, this is also how we define the product. Yeah.
Yeah, I believe so, because openness is the most impressive thing, in my opinion. Yeah.
Yeah, definitely.
And okay, for the modular design, for now, at this stage in this year, you're just focusing on the arms, right? Modular design for arms. But
yeah.
However, I do believe you must have other areas to explore.
Yes.
What is that?
Yes. I wanna say we have some very fancy idea in the house. We have some very fancy ideas in house on the hardware side and also on the software side. It's well, especially on the hardware side. We will make that happen till the end of this year, 2026. And the first shape of this robot or we are launching is a robot arm, but you can reuse everything we ship to you to build up another form.
Like what?
Maybe you can imagine, I think everyone have seen a lot of robots, like humanoid robots, leggy robots, maybe spider robots, and also and any other, or maybe go a little bit further. How about building a production line with our module? So this is not just a robot, it's an ecosystem, it's a platform, it's a hardware platform, and we are building like the foundation, like the from first principle, saying robot is small, but it is so from first principle, robot is just nothing but
Disassemble.
yeah, disassemble and then you reassemble it to another form and then you can control and use it. So yeah, I think
Yeah.
we'll see. We'll see.
Yeah, definitely, because user have to play with it. And one of the
Yes.
user has commented that Kynooe is just like the combination of toy and educational tools. I
Mm.
fully agree. So how do you think? How do you think
I
this
I
description?
I was so excited. Or I was so like when I see this come because this exactly what we wanted to do and define this product and well and the users just uh just have their very exact expression for uh, our our vision. Yeah, we are building something that um on the side of hardware is like something you can just use right out of the box. Right, you can open the box and and then you can use it. You don't need to you don't need to know how to code. And then education is just because or research level is because um, we are making this robot and we also prove it this robot could work and be compatible with the state of the art AI models or AI. Yes.
Yeah, I used to invest in we call deep tech hardware things,
Mm-hmm.
but I found out, well, especially in like AI hardware investment, it's so hard for investors to do the investment. Why? Because it's so difficult to do the definition of a product. So
Yeah.
many hardwares coming out last year, I think they all missed
Yeah.
the mark. There are a lot of wearables. Well, there's a good try to do the wearables, but sometimes it gives me sense of this is the stuff not the users want. This is the stuff
Mm-hmm.
that the founders wanted to just give to
Yeah.
give
Yeah.
to the
The shift to
investors,
the
give to the
yeah. Yeah.
users.
Yeah.
Yeah, they're not so useful. And so what do you think is crucial to do the define a product? Well,
Um.
the
Mm-hmm.
insight, the user insight.
Yeah. Definitely. That's a user insight or saying what we got from the user, like the feedback of users. I think that's a very important um, thing that we need to like put into our product, to put into the definition of the product. Saying, I am a user. I used to be a user of robots, so I have some insight. I have some insight of me, and I talk with a lot of friends. They are all in this robotics ecosystem or community, and then I know what they like and what they are concerned about product being deployed
Mm-hmm.
into a to C environment. So yes, from the definition of the product, we did have uh, think about a lot of how uh, so how they might uh, like mm, have their mm, thought about robots.
Mm-hmm.
Yeah.
This is a lot of nuances between that. So this is the balance that founders have to take into account when they define a product, I think. Okay,
Yes.
cool.
Yes. Exactly.
Yeah, I'm also curious about the software thing. And I
Mm-hmm.
know you are doing the remote controlling thing. Okay. So
Mm-hmm.
can we say remote controlling is like another foundation of Kynooe?
Um. Yeah. Uh. We used to have spend a lot of time doing this remote control. and by using remote control means you need to have your internet, which
Mm-hmm.
means it will um, have some concern for users about data um, security.
Data
And then
security.
yeah, data security. We are still on the thinking. We are still on um, thinking of if we are going to launch this kind of feature at the same time. But fortunately, or now everyone knows OpenClaw.
Mm.
OpenClaw, they supported. Um, they have different channels, which means if you have um, your OpenClaw running locally in your household environment, you can access it remotely using your phone, by using Telegram or Discord, by using this channel. So that kind of architecture, this kind of framework gave us a little bit um, thinking of saying, I mean, OpenClaw is actually a strength. I think in the future,
Mm-hmm.
everyone or many others will try it to maybe install it, and then we could just use this framework to help us to build up the software ecosystem a little bit. Saying uh, we could um, we could connect it our we can provide a connection. We could link the Kynooe product, the Kynooe One, to your laptop or to the server that are running OpenClaw in house, and then we can just talk to OpenClaw and to control the robot. And that's the way, because that's the way. That's also another way to do remote control. And people are generate or Peter build it a wheel, and then we don't want to build the wheel again. So
Mm-hmm.
that's the story. Yeah.
All right. So I want to move to the concept
Yeah.
of physical agent because I've heard this
Oh.
term from you several times,
Mhm.
and
Mhm.
I believe you must have some definition of what is physical agent in your
Yeah.
eyes. And
Yeah.
we all know it's a very prevailing concept that LLMs have made so much strides, and
Yeah.
there are a lot of advancements happening
Mhm.
recently.
Mhm.
But for like especially the household robotics, some
Mhm.
people would say, "Well, it's so far to
Mhm.
have the robots at our
Yeah.
home." Yeah. Do you
Yeah.
think it still take time, or what is the timeline? Do you think?
Yeah. It's hard for me to just define a timeline, but physical agent, or I mean, let's just uh, look at the AI agent. AI agent is something they could, um, unlike a LM, they could make decision, and then they can refine, and they could do the task you ask it them to do, agents. And then for physical agent, which means it could have some interaction or
Mm-hmm.
interaction with the physical world. And just like a robot is definitely, but robot with a brain, or robot with an LM on it, or robot with a at least a decision making center on the brain is a physical agent. But um, I think we still need time to develop this brain, but we could start from small.
Mm-hmm. Mm-hmm. We
Like
can start from small. I like
some,
this. Mm-hmm.
yeah, uh, we can start from small. By that I mean we could let um, the the hardware, or we could let. By that I mean we could have a um, form of hardware to tackle some easy task for you
Mm-hmm.
at the beginning.
Mm-hmm. Mm-hmm.
Uh, uh, saying saying you could um, do you think about it?
Well, just I want to talk. In my eyes, robots in China is like the buzzword, the most hot topic ever
Mhm.
in last
Yeah.
year. Yeah, and
Yes.
we are so crazy about what's going on next for robots,
Hmm.
but for like the physical intelligence, I think it's
Yeah.
pretty hard to get there. Physical
Yeah.
intelligence, or what is the bottleneck, you think?
Uh,
Is the
yeah.
data side
Physical AI.
to collect the
Data is
data?
definitely
Uh-huh.
one very crucial part. When we talk about bottleneck, and so physical intelligence or robots, what we're seeing right now, they have a brain, and the brain is actually doing, mm, in general, two different stuff. Like human beings, yeah, we have our brain, we think, we do decision, we have so depending on what we observe from this world, and then our brain is actually an end-to-end model, could output the next step. If I want to shake hand and I need to hand out my
Mm-hmm.
hand, so
Mm-hmm.
my brain will say, okay, you should hand out your hand to shake hand with Xiaohan,
Mm-hmm.
and then that's the brain, that's the what we call the decision making model, and that nowadays the LM, the vision language, maybe the multimodal language model, the VLM, could do a really great job because they have plenty of data in the internet, uh, uh, in and also image to train this model. And then the second layer, the second thing is the execution layer. It's
Mm-hmm.
what people call um, the low level control system, right? It's the like for example, like the locomotion, how the robot works, and the manipulation, how these two arms are reaching the specific location given by the brain. And this part is also quite mature using reinforcement learning.
Mm-hmm.
But now people wanted to, or now the but they're quite slow, saying uh, now you so if you combine these two in the traditional way that we have this hierarchical structure, like the robot needs to think, it takes some time, and then it need to execute. So the frequency is quite low, right? And now people wanted to build a overall model, end-to-end model, to combine these two, this so-called VLA, the vision language action model, which take the observation of this role from the robot and also the current state of the robot, how each joint, the angle of this joint, and then put inside the model, and then output is another, is the execution layer, is the action layer, is the
Mm-hmm.
how this robot could reach this direction. Then they could do a really high frequency up to um, couple hundred hertz, I think. Um, I'm not expert for that, but that's the idea of um, of the that's the idea of the foundation of physical agent right now. But now the bottleneck is the data. Like um, because like training a brain, training an LLM, we have tons of internet data, we have tons of images, but training this uh, this robot specific end-to-end model, we don't have this robot's data saying a robot is now in the stage one, including what if this robot see from this raw and RGB image, maybe RGBD image, and then the current angle of each joint, and then output is also another action space or another combination of joints. And then this kind of data we are still missing because it's
Mm.
quite new.
Mm.
People are starting to collect this data with different technique, and also others are doing some simulation. I don't want to comment on that. Maybe that's another new ways to tackle these issues. But now, yes, data is the bottleneck from what I see. Yeah, data is definitely now missing in this whole loop. So if you wanted to, because um, autonomous driving, so car is another form of robot.
Yeah,
right?
yeah, absolutely.
And then now people are talking VLA. Yeah, it's actually the same thing in robot, but maybe a lower number of degree of freedom. Right, car you just need car is working in a maybe in a 2D environment and can just and then but cars they have data, right? Everyone's driving on the street, on the road, and then they are collecting data every day, every second. But robots is not the case. So, and that's the thing that we are missing in robotics. Data is is mo I think it's the most important.
And did you remember the first time that we met in Shenzhen at your
Yeah.
office? You told me motion control is the key that you pay attention to. Motion control. 运动控制 kind of.
Yes. Yes.
Yeah.
Motion. We what we want to do we want to because we have this distributed control system. It's not like the bus control system like many other robots. So we want to prove is the motion control with our fully modular design work as well as the others control system, and then we managed to prove it. Yeah, and then we did.
Yeah, yeah, yeah. Sure, sure.
Yeah.
Well, you're about to launch on the Kickstarter, right? And yeah, you have to deal with some supply chain things. How is going
Yes.
on? And tell us about the challenges involved with the supply chain thing.
Yeah. In Shenzhen, I think Shenzhen is the best place for developing hardware, and so that's the reason why we choose Shenzhen. We have a lot of ready to use supplier for our product. So we are quite confident for building a mature hardware using the help of them. Yeah, the most tricky part is I think will be in the I don't want to say that, but yeah, I think that's it. So we're in Shenzhen. We are quite lucky to have a lot of supplier like surrounding, and also in the product developing phase, we got packages every day. So the new supplier will ship up a new motor, the new PCB comes, and then new chip, and then the battery. So we are so lucky to be in Shenzhen to developing hardware. I think that's the best that's the best place. Yeah.
Yeah, I believe so. Shenzhen is the hub, and your guys are at the fastest pace, I think.
Yeah.
Right?
Yeah.
Good. Well, and for a lot of builders who want to launch their products on Kickstarter, you guys are like the same group of people.
Yes.
You are all builders, right? And well, what sets you apart, you think? What makes you standing out among them?
Yeah, I think first of all, we are all passionate about hardware. So we all wanted to ship something useful in the real life to user. And for I just me myself, I don't know about others, but me myself, most important thing is delivery. It's really to
Delivery?
yes. So I launched a product, and now we have a lot of feedback. We have a lot of positive, negative feedback, and some people will buy our product. And then we need to manage to ship the product to users' hand, and that's also a big step doing hardware. I mean, doing like I said, it's a totally different story when we are doing hardware. So yeah, so now we are managing to do this part, to tackle this part, and yeah.
Yeah, hardware is like a more comprehensive, complicated, systematic thing compared to software. Yeah. Because
Yeah, there's a
right.
whole bunch of stuff to coordinate, if you will, in the
Yeah, because
hardware.
yeah, well, shape delivery in software is very simple. You
Yeah.
order it, you just have it. But for
Yes.
hardware, you have to deliver it on time. That's a
Yes. Yeah.
challenging part, I think.
Yeah.
You
Yeah. Yeah. And
mm-hmm,
also, I think iteration in software is also it's an overnight thing. You can just fix this bug and then you upload the new version and then that's
mm-hmm,
it. But for us, we need to make sure this product it's um is prepared enough in
mm-hmm.
many ways, in many aspects uh, before we sign the paper, before we like ready to ship it. Yeah.
Yeah, that's true. And tell us about your team. Well,
Uh.
how many members in your team, and what is co-founder, and what kind
Yeah.
of individual talents you want to hire?
Okay. We are a team of now. We are a team of 5 people
Mm-hmm.
now. Wait a minute. Let's think about it.
More than five, I think.
Yeah, we are a team of 6. I don't wanna. I don't wanna. Yeah, we are a team of 6 right now, and then we have a lot of um outsources.
Mm-hmm.
Is that the word?
Mm-hmm.
Yeah, I think we have, and then we have a lot of outsources to help us. We cooperated with a lot of high experienced
Mm-hmm.
agency and also another firm work together to make this happen. And then now um, we're actually looking for mm,
Marketing?
yeah, I think we are now doing we are doing that now we are doing I think now we are doing good in the
You don't need talents, right?
yeah, I think we are doing yeah. It would be great if someone in the marketing domain join our team. No,
You're
at
not
this
hiring?
moment I don't think so. I'm not hiring.
Oh,
I'm
okay.
not. We are quite comfortable right now. We're quite comfortable because we could outsource a lot of stuff and then marketing. We are a startup. I think startup it's too expensive. I mean it's not it's too expensive for a startup um to hire people um or it's quite expensive for startup to hire entry level marketing members.
Mm,
We
mm,
need to
mm.
hire the a bit higher level
Experience?
marketing
Mm-hmm.
experience. Yes, exactly. That's word. Experience member into the team, or we could cooperate with other the external marketing firm.
Mm. Yeah, yeah, yeah. Yeah, that's another form of companies look like in AI era, I think. Because I've asked a lot of software companies, they won't hire like more than 50 people, even though they can hit
Mm-hmm.
the like the 100 million AR in the
Oh,
future.
cool.
So yeah, that's the essence of the structure would be like for corporates.
Mm-hmm.
But in hardware, what do you think would be like the maximum team members within a company, you think? Because hardware,
On
you have to,
hardware,
yeah, you have to, you don't have to deal with manufacturer things, right? You just outsource
yeah,
it, you
no.
have the
Mm-hmm.
specific vendor. But in the future, maybe if you just grow up like a big giant company, you have to deal with the
Yeah.
manufacturer things. Uh-huh.
Uh, Let me put it this way. It depends on how many um, product line that this
Makes
firm
sense.
will want to build. Like we have now one product line, maybe we will have another one, and then I would say one product. Um, so five like you can we can just do some very simple calculations. Like we are in a group of 6 people, and we are comfortable because we have the software engineer, we have the hardware engineer, we have another engineer doing the coordination of these
Mm-hmm.
two, and then we have the industrial design. We have the yeah. This is actually, I think, one product line. It's 5 max uh, for a startup, and I think it's quite comfortable.
Well, you know what? A lot of VC just like standing out of the office, like DJI, Anchor,
Yeah.
Insta, in
Mm-hmm.
Shenzhen, and
Mm-hmm.
Bamboo, right? Because they
Yeah. Yeah.
want to
Yeah.
just wait for someone who just resigned their job from these giant companies and
Yeah. Yeah.
do their own startups. But my thesis is I just want to focus on some builders like new grads like you, just
Mm.
graduate, but you're just very passionate about what you're building and you have
Yeah.
the vision and you know
Yes.
what's going on. So my point is,
Mm-hmm.
maybe the thesis is, especially the investment thesis, just
Mm-hmm.
shifted from the
Mm-hmm.
traditional hardware things to the new hardware companies because your mindset has shifted. Your like corporate structure has shifted. You don't have to
Yeah.
hire so many people.
Yeah. Yeah. We don't, especially in this AI era. So
So
we
the
have all this
orchestration,
AI.
yeah,
Yeah.
the corporate orchestration
Yeah.
just switched in
Yeah.
AI era, I think.
Yeah.
So
Totally agree.
we need new spaces like Kynooe, right?
Yeah. Yeah.
Okay, so at
Definitely.
last, just tell us how can we purchase Kynooe? Where should we find it? Interact with it and engage with Kynooe.
Yeah, we'll be launching Kynooe in 2 months on Kickstarter, and yeah, and we'll just come and buy it.
All right, and just stay tuned on Reddit and also
Yes,
Randall, right?
yeah. So on the product, we are gonna launch this product officially on Kickstarter in 2 months, and then before that, we'll do a lot of um these pre-launch events on Reddit, on Facebook, and then maybe you've seen our product while you're using Facebook. I don't know, but
Instagram.
just yeah, Instagram. Just feel free to click it and support our little Kino one.
Yeah, absolutely. I can't wait to see your video, promotion video on social media. Just do it.
Okay. Yes,
Cool.
that's it.
Cool.
Cool.
Thank you, Guowei, to join Sha Talks. And I think we have a very good conversation. Very happy to have
Yeah.
you here. And we want to see more progress happening on Kino. And
Mhm.
probably we will invite you again after Kino 2, 3, 4 launch.
Yeah, definitely. Thank you, Chan. Thank you for having me today.
All right.
Okay.
That's all about today's episode. Bye bye.